Hello, and welcome back to another episode on math and science problems. On this episode, or on this video, we will be working on the density formula. Now, the density formula is something that we all use, but unknowingly, if that makes sense. So, to make that make sense, let's talk about it. So, the density formula is equal to D equals M over V. Now, this formula is somewhat similar to the distance, rate, and time formula. However, this formula has different variables that mean different things. So, the D in this equation is for density. I'm just going to shorthand that to den, D-E-N dot. The M in this equation is for mass. And the V in this equation is the volume. Each of these three variables can be manipulated to find the other, and each of these variables can also be manipulated as different, not different objects, but different units to measure. So for mass, mass is necessarily, or essentially, is the weight of an object. The volume is the space, and density is necessarily how much something can pour down on something. So it's almost as being viewed as how dense an object is necessarily. And that's clearly found through doing mass divided by volume. So if I had a 5 pound, or let's say I had a 15-pound dog, and I had, let's say, a space of cubic meters squared, cubed, and I had 5 centimeter cube space. Okay. Now to find the density, I would simply just do 15 pounds divided by 5 centimeters cubed. Now, this is the tricky part. We cannot always divide by certain units. We have to convert units into specific units. So when we divide by centimeters cubed, we have to use liters. So in this case, we have to convert 15 pounds to liters. Now, we will discuss units and measurements and conversions in a different lesson, but as of right now, 15 pounds is approximately 6.8 liters. And that could be water, juice, anything. 6.8 liters. So, referring back to our equation right here, our density is equal to 6.8 liters, never forget the unit, divided by 5 centimeters cubed. And when we plug this into our calculator, and we do 6.8 divided by 5, we get that our density is approximately 1.36. Now, a little interesting thing about density is that density tells us how it can be compared to different densities of other objects or liquids. So the density of water is 1. So anything that's more dense than water will sink. So in this case, whatever our substance is, since it's greater than 1 and our answer is 1.36, we know that since it's more dense than water, it will drop down to the bottom of water. So say this is our water. This would be our liquid or a substance, because since it is less than, or since it's more dense than water, it drops to the bottom. And that's why when we see a cup and we have, let's say, oil and vinegar, there's a separation between the two. Say this is oil, say this is vinegar. There's a separation between the two because one substance is more dense than the other. And that's strictly found between the mass divided by the volume. So a certain amount of space are what we're measuring by, and then the weight of the object when given a specific unit, such as liters. So this is just one prime example of how the density formula can be used. We will make another video talking about conversions and how they are related to the density formula. Similarly, the density formula can most likely and mostly is used in chemistry, such as finding the grams over the moles. And grams and moles is all a whole nother topic that we will further discuss. But this is somewhat of an introduction to the density formula and how it can be used. So just a quick recap over today's lesson. We talked about the density formula, which is D is equal to mass divided by volume. M, the mass, is also known as the weight, and then the V, the volume, is also known as the space. And when you divide those two, you come up with the density. We did a short problem. Density is equal to, say, 15 pounds over 5 centimeters cubed, but the rule is that we can only divide by specific units, so we had to manipulate the specific unit measurement. So we had to convert 15 pounds to 6.8 liters in a converter, which we will discuss later on this channel. And we found that 6.8 liters divided by 5 centimeters cubed is approximately 1.36, which is the density of this substance. Then we talked about how water has a density of 1, and anything that is greater than 1 will sink. And in a reference to that is oil or vinegar, or anything that can separate. Now, quickly before we end, I wanted to quickly touch upon how we can manipulate these variables. So in this equation, we have D equals M divided by V. But say we're only given the volume. So if we're only given the volume, how would we find the other variables? Well, if we multiply, let's change this to a different color. If we multiply by V on both sides, these V's cancel out. And that means we're left with V times D. Now we must divide by D to cancel out this D. And then we have a D, M divided by D. So to find, if we're given the volume, or if we have to find the volume, we would do mass divided by the density. Now say we're only given the mass. If we go back to our original equation, we can see that D is equal to M divided by V. So if we do M is equal towards, we just have to multiply by V on both sides. And we have isolated our M variable, so we know that mass is equal to volume times density. So if you remember from our previous videos, this is highly similar to the distance rate and time, and how we're just simply manipulating variables. And if we quickly do this, just to show you how this can be referenced, if I wanted to find, say, the mass, so we know for our problem down here, we wanted to find our mass, and we know that our mass, well, let's say we don't know our mass, but we know our mass is 6.8 in this case. So to find our mass, we set that it's V, our value, times our density. Now, our density is 1.36, and our volume is 5. Now, if we do 5 times 1.36 in a calculator, we will approximately get 6.8. And you can double check that too, but I'm pretty sure it would be 6.8. So this is pretty interesting how we can manipulate variables to figure out another variable. And that truly shows how all of this stuff is integrated together to fully be open to different unit conversions and all. Thank you so much for joining me today on this episode of Math and Science Problems. We will discuss more on unit conversions and how they can be related to density formula and chemistry in total. Thank you so much for tuning in, and I will see you on the next video. Take care.